Hello, beautiful people out there. Today we are starting with our new series, which is image processing with Python. And this is the first video which deals with the basics of image processing. We are basically dealing with the very fundamentals of image processing, how it works, what's the difference between a human eye perception and how the computer looks into it. We'll be looking at certain color segmentation options, how to extract the figures, how to uh, you know differentiate between the various color channels. So it will be a fun journey today. So stay tuned and let's meet at the other side. Okay. Okay, so let's just rename it first. Basics of image processing. So the same notebook will be provided to you under the GitHub section, so you can check out the description and you can click it over that GitHub link so that you can clone it and you can play it around as per your requirements, right? So how a human eye perceives an image is practically because of this patterns, right? We generally don't see numbers behind it. We as a from the human side perspective, we deals with the patterns or the shapes or the sizes, which ultimately defines uh, at the end of the day defines an image. For example, let me just quickly pull out what you say that image over which we will be working on today. So just a second, guys. Okay, so here's an image of a bird, precisely a parrot, right? So if we look at it closely, how we are going to know that it's a bird? First of all, we know this beak-like structure, then the eyes, then the feathers, then the claws, and once we are done with all these definitions, we are like, okay, now this is a bird. And based on the color and composition and differentiation which we have learned from the childhood till now, so we are pretty much trained to identify, like, okay, so the first category is like this is classified under the category of birds, and secondly it's a parrot, right? But if same thing has to be done by the computers, how would we do? So we'll be looking at it from a computer's perspective, of course. So let's start with like importing our initial libraries. Just a second. Okay, so today we'll be working at okay, so today we'll be working with the first library in Python, which is the state of the art and which is widely used for whatever which is related to computer vision. So the name of the library is OpenCV, right? So let's just simply import it. It goes by the name CV2, right? Reading images. All right. In case you want to install it, just simply type pip install OpenCV Python and you would be able to download this library in your Python terminal, right? Just another library in case we want to plot down the results and see the results inside the notebook itself. So matplotlib is one of those libraries which will help us out on the same. Okay, plt, great. Okay, so I guess this should suffice our needs for now. Okay, so let's just read the image. Right, so name of the image is, I believe it's parrot.jpg, if I'm not wrong, but still let me confirm. Yeah, it's parrot.jpg. Great. So okay, and let's just read it for the time being. CV2, we are using imread module of the CV2 library, and we'll be just passing the the path of the library which we want to read, and let's see. Okay, so we have our image with us. If you want to see, so this is basically how a computer looks at a certain image. So whatever you are providing to it, it will basically converts that whole image into a matrix formation. So if you want to see like what's the shape and size of this matrix, so we can do one thing. We can simply print down the shape so that we can look what's the shape. So it's a 2590 by 2072 image, an RGB image. So here 3 defines the RGB channels, which is the red, green, and blue. The 2590 is the number of rows it has, while the 2072 is the number of columns it has, right? So this is basically the total size of an image. So you guys might come across like we are working with, let's say, 720 pixel videos, or maybe we are working with a specific camera comes with like an HD image quality. So what that HD represent, that HD video or that HD image represent that 720p, which is loosely can be translated as 720 cross 1080, right? So ideally it should have a 720 rows and 1080 columns, or vice versa, whatever suits the best based on landscape or portrait, whatever format you are using, right? So this is how a computer, if you want to visualize this, let's just like visualize it right away so that we can see how image look like. So I'm just passing the image parameter over here, and let's see how it comes out. Okay, so we are having a parrot over here, but wait a second, there's something which interesting comes over here. So if you have to look at the original image, right? So you will notice that this parrot is pretty much red, right? But what we are basically seeing over here is blue. So how is it working? So this is just because of this very simple fact how the channels are rated in a given library. So suppose if you have performed the same operations under a different programming language, or maybe under a different a library, the result would be different. Just to show you the same difference, we will be importing a new library, which is Pillow, of course. And Pillow is basically used for like certain image related manipulations and image related operations. So let's just import Pillow and let's see how basically it reads the same image, and you will clearly able to see the difference. Just a sec. Okay, great. So if I read the same image, let me just name it to like img2 and image dot open. So we are just reading that the same image, passing the paths over here, and let me just plot it over here so that basically we can see how it turns out. Okay, so if you look over here, you will understand that so this is the actual colors which were in the actual image, right? But on the contrary to this, when we plotted with the help of when we try to visualize it with the help of CV2, what it gains is like, instead of reading it in the RGB channel, it end up showing us BGR. So that basically depends on the different libraries which you guys will be using. Instead of Python, if you guys are using like MATLAB, for example, for MATLAB is a widely used academic based software. So if you are using it over MATLAB, so that MATLAB will be giving you the exact colors, because it reads an image in the same order, which is the RGB. So this is something which we need to be like be informed about before using certain types of libraries, and that would help you in the longer run, because that is something which will help you to manipulate these channels and get the the most desired features of the libraries at the end of the day, whatever you are trying to manipulate it, right? So great. So let's just do certain normal operations. So we do have this library over here, and let's just resize it for the first time. Like we are working over certain task where we need to resize an image from a very, let's say we have a very huge image and we wanted to scale it down to a level where it simply comes to a point where we can basically actually picturize it, right? So in those scenarios, we have to resize it, and when we are resizing it, of course there is this quality loss, there is this pixel loss. So let's just see how it's done at the coding end, right? So just to have a fair idea, like you guys must be, like whenever you guys are going to submit some sort of a form, you ended up having, a big resolution image, so called big resolution image. So and the overall size of that image is, let's say, 5 MB, but the restriction is of 2 MB. So what you do, you compress that image or you resize that image so that the whole size of that image reduced out to a lower, much lower scale. So we'll be looking at like how we are resizing an image, right? Okay, so let's see how it works, and I'll also showing you how this, I'll be also showing you the difference between the two images, like the non-resized, the original image, versus the resized image, right? Resizing the image. So okay, so let's make a variable resize image, or let's just call it like new image for the time being. So cv2, there's this function which is in cv2, and that is cv2.resize. All you have to do is like you have to provide the image, and then you have to pass an array where the first will correspond to the rows and the second will correspond to the the first will correspond to the columns and the second will correspond to the rows. Let me just see. So I am just resizing it to a 640 pixel based density. So it's 640 into 720, right? And just to verify that whether we were able to do that or not, I'm just simply, checking the shape of the output matrix which we get over here. So I guess, okay, perfect. So we do ended up resizing this image. Okay, so just to give you a quick demo, like if suppose we fail to resize it, how it would have worked or how it would have looked. So in for that particular thing, let me just sorry for this screen resizing. For that particular thing, let me just quickly import a library. That library is basically nothing but a function which has been saved to a different Python file, and I'm just importing it from there. So I believe from utility import img show. Let's say it works. Okay, great. So I'm gonna show you both the things. So let's just show the first image, how it's working at the end, to also just to give you an idea like how that backend looks over there. So I have done nothing over here. So if you look at this function, all I'm doing is like showing the image and resizing it, because without resizing it, what will happen, it will show me the like the greater image, and I'll show you how it works, right? So suppose if I simply pass this new img image, or suppose if I just simply pass down img1, which is our base image over here, right? And we just pass down the two values. First is the like original size of the image, which is 2590, and the second value is like 2072, which is the original size of this image. And let's see how it works, or how it comes out. So this is the, like, if you can see, this is the bigger chunk of this image, and my screen currently fails to reproduces because of the current screen resolution. So if you want to like visualize this over the screen, then the good idea is like to resize it, so that at least we would be able to see it. So here you are able to see the actual image, and you are like, this image has been rescaled to this same level which we have done over this new image thing. That's why we were able to reproduce it, or we are able to see it over here, right? So these are like quite a few things which one should keep in mind, like how the image works, even if you want to visualize it, and even if you want to work over it. So you need to be very much uh, very much aware of the things how it's working in the end. The second thing which I would like to discuss over here is like how the channels work, right? So there are multiple images which are like the raw images which contains like the four channels, like RGB values plus an alpha channel which is basically related to the luminosity or the light related conditions. We do have RGB images with us. Then then there is this thing called grayscale images. Then we have black and white images, then have bit images. So there are several other formats which is basically which basically caters to different objects, and which basically help us to target different issues. So if suppose if your guys are working with ML or computer vision related tasks, so there's high probability that instead of using the color images, you guys will be either using a bitwise image or maybe a grayscale image, because then the system has to do a lot less task as compared to the three channels. Because what will happen in the end is like for each and every image and for each and every iteration, that same function has to go across the three channels. So whatever is applied to green, you have to apply for blue, and then red as well. Or maybe there are different operations with respect to different channels. So it is like really a resource expensive task. So let's just see like how the channels work over here. So I'll be just watching over like quickly walking you through over it. So okay, let's just so we know like this is how Python conventions work. So all we are doing is like retracing the things which we wanted to work over here. So here the zeroth, so as you can see over here, right, we have three channels. So this is the length and the width of the images which will be constant, and we have to now retrieve these three channels over here and see how the difference comes out to be, right? So let's name it like this is a blue channel. Similarly we can go for the green one. And similarly we can try for the what we say right. So this is for the green one, and this is for the blue one, and this is for the red one. All right, let me just make it look a little better, I believe. Okay, perfect. So if I run across these things and if I simply let me just show that either of the colors to you guys. Let's just basically visualize how the red look likes, right? So here you can say this is actually how the red will look like in the actual. So if you will look over here, the more the value of red is, the higher the value of luminosity will be present over there. So higher the value of the pixels or higher the color accuracy will be there. So if you simply compare it with this current image which we are having over here, right? Okay, let's just do one thing. Let's just open it side by side. So if you can compare over here, so images like, so the regions where the red color is the most dominating one or the most prominent one were having like bright pixels. And if you look over here, the lower down value of this, so L represents the luminosity value of here, how luminous is the image. So you will understand the value is pretty much high. But on the contrary to this, if you look at these blue regions, so here the value will be like pretty much literally low, and the zero basically represents that it's completely black. The more the color will be deviating from the red zone, it will be more under this darker shade as compared to the regions which are under the black, which are under the red, sorry. So this is how the things are working over. We can we can see with other things as well. Suppose if I just open it with the green part, and if I want to visualize how the things over here. So okay, so from here onwards, from here itself, you can notice that the regions which are having green, so suppose we have green over these feathers, so these are pretty much having high values as compared to the other places where the red is the dominating one. So most of the image you are seeing over here is pretty much black as compared to the regions which are either on the bluish side or maybe on the yellowish side on the green, because this is somewhere in the same zone. So rather than blue, we all know that it's just like completely opposite to each other. That's why you would be seeing over here. So suppose you have and just for the reference sake, let me just pull it out and let me just show it the blue region to it so that you guys would be able to understand it in a much wider way. So now we have now you can see that how it looks. So bluer region will have again the higher levels of luminosity as compared to the red regions or the other regions, and it's clearly visible over here, right? This is something, how this is how the color works in the real life scenarios. And welcome to and the best part is, like, this is how the filters are made these days. Like, you guys must be very fond of Instagram filters, and there's this new trend of uploading a good grayscale image or black and white image, just to maybe some nostalgia associated with it, or maybe just for the fun sake, because it looks more cool. And there are these filters where a person, the only color of your shirt, like suppose you have wore a blue shirt or maybe a a red shirt, so that red shirt so you pass it to a filter, and then only the red color remains, rest everything fades out, or rest everything is converted into a complete black and white sort of image. So what's happening in the back end is just the similar thing which I done in front of you. There's this simple function which is running at the back end. So congratulations, you guys now know how filters works. That's the very basic, but yeah, there are several much more complex algorithms attached and associated with it. But yeah, now you guys can save down your own filters now, you and try your own filters, and save it down, and just don't forget me to tag it over my Twitter handle, which is cipher_sudo, so that I can have I can see like how well you are guys performing over there. Okay, just to give you last thing, just to give you, although I have shown you like the how the comparison works, how the things are working over here, right? I'll be just giving you a very quick, quick plotting of the same, so that you guys can visualize under the same space. Although we have seen like how it looks, and in the given scenarios, or how each color reacts to the same things. So what we are going over here is like we are like quickly plotting the things, and let's just define few parameters. First is like figure, second is like axis, right? And there is this function in the plot module that is a subplot. So what we have to provide it over here is like the number of rows and columns we want to plot our given graphs or given figures. And then we need to define the figure size, like what will the figure size of the whole plots. So I'll be keeping it like really small. So let's say how about 10 cross 10. We just wanted to visualize, that's the base whole idea around here. Let's just also provide a basic subtitle, super title. So what it does is it'll simply provide a title to the whole plot which you have created, in fact a generalized title. So okay, so as we are using this image one, which is a BGR based, so we can simply see color segmentation in image, color segmentation in image, right? We can also okay, I hope that that works fine over here. Let's just create two arrays. First will be the collection of images, of all the images which we wanted to present over there. So image ls, that would be the like list of the image, or let's just simply call it image array. So first image would be like So first we'll start from blue, and we are just appending all the images into the same list, so that we can iterate it over and we can get the results. Then green, and then red, and finally we are just getting the original image. And then we'll be gathering the titles for all these image, because we want to represent, and you want to basically identify like which image is which. So let's just simply type it down: blue, then green. This is basically the color channels associated with this, with each image. And finally the original image, right? So subplot subplot, all right. Okay. Now let's just display all the okay. So I'll be just iterating it using a keyword, using a variable count. So for I in range, right, for I in range, so we have 2 rows. Then for j in range, then we have 2 columns. And I'll be just simply iterating it with I colon j, so that basically we can display it in iterated way. Otherwise we have to do the same task and repeat the same code again and again. So it's better just we can just simply automate, or we can loop in the process. It is easier in the longer run. Suppose if you end up having 100 images, what would you do? You will be copying. That's not an ideal case, or that's not the good choice, in fact. So we'll be doing the same. So here we have this array of ours, img.array, and what we'll be passing over here is the count part, right? And then same, and what we are going to do is like we will be like setting title, and we are getting it from the titles array, I believe. Okay, so this, and all that is left to pass is the count variable which we created. Okay. With each iteration we simply increase the value by 1, so that it can iterate it over and over again. And let's just see the output. Okay, so what's it saying? I guess I have subplot takes, so it's saying subplot takes 1 or 3 arguments, but two given. Let me just see where we have done wrong. So pld.subplot. Okay, so this is supposed to be subplots instead of subplot, because we are plotting it like multiple values over here. So I guess this should solve the issue over here. And voila, this is the image which we got. So I don't know whether it's visible to you or not, but this is the blue image. Like if I could open the image in new tab, so you could be able to see this. So this is the blue image, this is the red one, and as I've explained to you over again, so these are basically the luminosity channels, or the light channels, which indicates how much color is present in what order. And this is the final image, right? So you can, like, if you want, you can simply save it and visualize it later on. So this is how the things are working over here, I guess. And the one last part which we'll be discussing today is like, if suppose if we want to gather if we want to just have a part of an image, so what we'll be doing, right? So let's say extracting the part of an image, right? So first of all, let me just show the image first. So here we'll be using the new image because that would be easier for us to track, uh, right, instead of the big one. So let's say, okay, so we do have this image now. So how a system reads, so the coordinates as opposed to the real world coordinates, the coordinates are always inverted in the images when you will be plotting it or when you will be displaying it. So at this particular corner, which is the left top corner of the image, that is basically 0 cross 0, so 0 comma 0, that will be the x-axis, that will be the y-axis. So if you can if you can look over here that specific value, so that will indicate like how much value is changing along with the time. So if I keep it over here, you can see that value is pretty much high, and if I increase it over here, both the values are increasing at much rate. Also, there is a point to notice that if I hover any part of this image, you will be seeing that there is this RGB values, and that is indicating the total amount of the red color or the color channel present in the given image. So more the image, so more the color is present, the higher will be the values of the same thing. So here the R will be highest, here the B will be highest, right? So it will be ranging something, I guess, close to from 0 to 255 if I'm not wrong. So that's the one thing. Now suppose if we basically if we want to extract this eye out of this whole image, what we can do is like we can take the coordinates. So here the coordinates are like if I can zoom it over here, you guys would be able to see over here. So let's suppose if we simply want to extract these eyes, so let's just hover it over here, and we can easily see that its x is like close to, we can start from here, from this part, and then we can end up from till this part. So if somehow we would be able to create a box around it, this specific eye will be traced on from the given image. And this is pretty much very simple. So suppose I'm just providing with the x1 y1 values. So I guess that was close to 190, and the y value was okay, let's check again. So y value was 70. So let's just keep it 70, that's fine. And here the y is, let's just keep it 100, and x is 230. All right, so here let's just keep it 70. So this is called simultaneous assignments. In Python we have this capacity to assign multiple variables, multiple values in a single line, and then we will like x2 y2 and 190. Here I guess the value was 225 or 230, I believe. Okay, so 230 and it was 100, right? And what we can do is like we can basically pretty much slice down the image, and we can get the required part over here. So we are using over here, we are using the new image, right? So let's just pass number of columns first, y1 y2, and then x1 x2. So what will be doing, it will be tracing from 192 to 230 rows, that will be the x-axis, and sorry, the number of columns from 190 to 230, and the y will represent basically the number of rows it will be extracting from it. So I'll be just showing it to you. img show UIS. So this is the very eyes which we wanted to extract over here. Let's just simply plot it down. Okay, so this is how the eye looks. That's all for today's session. I hope this session helped you out in any manner. Do let me know if you have any doubts in the comment section, or you can reach out to me directly over my Insta handle, which is sudo_cipher. Rest of the things you would be able to find in the description itself. And yes, do try to perform certain filters operation, try to upload it over Twitter, and do tag me so that I can see how well you guys are working over there. So yes, thank you so much guys for your wonderful day.